So hello guys, today we are discussing about Rolle's theorem. The statement of Rolle's theorem is if f of x is continuous on a comma b and differentiable in a comma b such that f of a is equal to f of b where a and b are same or real numbers, then there exists at least one value c in a comma b such that called as f dash of c is equal to 0. So the meaning of this statement here, what the so here the theorem is saying about the function f of x. F of x is continuous on a comma b, and also it is differentiable by a comma b. It is continuous on a comma b, and also it is differentiable. So what is there? They here a comma b are the real numbers. Real numbers, as you know, 1 2 3 blah 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 blah. So when this condition will happen, when when function is called as continuous and also differentiable for by the a comma b, then there is an exist value, that is an least value of this a comma b is called as f dash of c. That is called as c, and the value when we use c in functions, then it is as f dash of c, which is the differentiable of f of x. Where when we differentiate the function f of x with respect to x, then it will become f dash of x, and the f dash of x and f dash of c is same value. So here what is saying, the value c in a comma b such that f dash of c is 0. When this condition will happen, then f dash of c will be 0. So this is the condition for the theorem. Let we understand this by a problem. Here is a problem. We have to verify Rolle's theorem for the function f of x square plus 2 in minus 2 and plus 2. So first, as you guys are remembered this Rolle's theorem, so let me dive in. What are the given we have? That is first one f of x, that is a function x square plus 2. Another one is the values a comma b. What are those values? Minus 2 and 2. 2 f of a. First we have to do the what is differentiable with a using a for f of x. So first we use we replace x as a, f of a. So what is our equation? X square plus 2. So what is a value? Minus 2. Minus 2 square plus 2. What is the value of this? That is 2 4 plus 2, that is 6. F of a is 6, same as f of v. In f of v, x square plus 2. What is the value of b? 2. 2 square plus 2. 2 square's value is 4 plus 2, it is 6. So here what we get? F of a equal to f of v. So both are same. Now let mention it as equation 1, and this has equation 2. Now differentiate equation 1 with respect to x. So what is our equation 1? F of x, that is given value x square plus 2. Now if we differentiate a function with respect to x, then it will become f dash of x. and differentiating x square plus 2, x square differentiable of x square with respect to x is 2x, and 2 is becomes 0. Now f dash of x is equal to 2x. Already in theorem we have already mentioned that f dash of x is same as f dash of c. So f dash of x is equal to f dash of c is equal to 2x. So mention it as equation 3. Let f dash of c is equal to 0. In previous we have get the f dash of c value. So what is the f dash of c value here? That is 2c is equal to 0. We replace x with c as we know. Now take the 2 to that side. Here it is multiplier. When it goes to other side, divided. Now then we get the value c is equal to 0. So in last we get the value c is equal to 0, that is belongs to minus 2 comma 2, such that f dash of c is equal to, what is the f dash of c? That is f dash of 2, f dash of 0, sorry, f dash of 0. And what is the f dash of c in previous we get? That is 2c, that is 2 into 0, nothing but 0. Hence proved. Hence Rolle's theorem proved. Second one. Let's start the new problem. F of x is equal to x square minus 6s plus 5. This is our equation, and the values are 0, 6. Those are the real numbers. So take it as given f of x function it as equation 1. So first we have to do f of a, that is what is our equation, x square minus 6x plus 5. F of a, what is the value of a? That is 0. 0 minus 6 into 0 plus 5, it is nothing but 5. And what is the value of so now we have to do f of b, that is x square minus 6x plus 5. And what is the value of b? It is 6. 6 square minus 6 into 6 plus 5. So here 6 square is nothing but 36. 6 into 6 is 36. 36 minus 36 is 0 plus 5. The answer is 5. So the f of a is 6, f of a is 5 and f of b is 5. So the condition f of a, hence f of a is equal to f of b. So after this we have to differentiate the f of x with respect to x. So let's do that. Differentiate f of x differentiate equation 1 with respect to x. So what is our equation? F of x is equal to x square minus 6x plus 5. So after differentiation the f of x will become f dash of x, and the equation will become x square is, after differentiate it is 2x, 6x will become 6, and it is 0. So take it not to write it. So now we have get the f dash of x, as we already mentioned in theorem. F dash of x is equal to f dash of c. So we just so that's why we write for f dash of c also is, we replace x with c as we replace in function to C. So now let's take in theorem what we have said, f dash of C is 0. Let's take that f dash of C is equal to 0, and here what we have get, no we mention it as equation 2. What we have get, that is f dash of C is equal to 2C minus 6. 2C minus 6 is equal to 0. When we take 6 to that side, that is become plus 6, and when we take 2 to from that from this side to that side, it is here multiplier, then here it will become the divider. So C 6 by 2 is answer 3. So now we get the C is equal to 3. So no, when C is equal to 3, that is belongs to 0 comma 6, such that f dash of C, we have to solve f dash of C also. Here we only get the equation, we have not get the value. Here we get the C value. So now we put C value into this equation. What is our equation? F dash of C, that is 2C minus 6. So what is the value we have get? That is 3. So 2 of 3 minus 6, that is 0. Here we get f dash of C is equal to 0. So it is our final value. So hence it is proved. Hence the Rolle's theorem proved. So another problem, it is f of x is equal to x square plus 2x minus 8. The value we have, that is minus 4 and 2. Those are the real numbers, and this is our equation. So let the function as equation 1 and dive into this question. First we solve f of a. So what is our function? X square plus 2x minus 8. We have just replaced x with a. That is first f of a. What is value of a we have? That is minus 4. F of minus 4 is equal to minus 4 square plus 2 of minus 4 minus 8. So 4 square's value, that is 16, plus 2 into minus 4, that is minus 8. Minus 8 plus into minus, that is minus 8 minus 8. Minus 8, that is minus 16. Minus into minus 8 is plus. Then 8 plus 8, that is 16. Minus 16 plus 16 and minus 16, that is 0. What we get? F of a is 0. And we have to do f of b. X square plus 2x minus 8. What is the value of b? That is 2. 2 square plus 2 of 2 minus 8. What is 2 square? 4. 2 into 2, that is 4. 4 plus 4, that is 8. 8 minus 8, that is 0. Here also we get 0. So for there, f of a is equal to f of b. Now we have to do the differentiate of the function. Now differentiate equation 1 with respect to x. So what is the equation? F of x is equal to x square plus 2x minus 8. And after differentiation, it will become f dash of x, 2x plus 2, it will become 0. So let it be. And as in previous problems, f dash of x become f dash of c. As it is, we replace x with c, 2c plus 2. Now let we have the f dash of c. value is equal to 0. So now we have to find the value of c, or the real value of c. Now then we have to solve this equation. F dash of c, as we already know, f dash of c is equal to 0. Here equation what we have get, that is 2c plus 2 is equal to 0. When we take plus 2 to that side, that will become minus 2, and when we take 2 to that side, it will become divided by, and minus 2 divided by 2, it is minus 1. So here we get the c value is minus 1. So then now how to get this f dash of c value. So now f dash of c is equal to 2c plus 2. Now put the value c in equation 2. Here I will write, put the value c in equation 2. Here what is the value of c we get, that is minus 1. 2 into minus 1 plus 2. 2 into minus 1, that is minus 2, that is plus 2. Here it will get cancelled, it will become 0. So hence proved. That's it, guys.